Warning, do not attempt any industrial electrical troubleshooting until you completely understand the dangers of the system. This includes arc flash and electrocution risks. Today we're going to go over how to troubleshoot a three-phase motor in a system. What many YouTube videos will attempt to do is to teach the watcher to troubleshoot with the component already removed from the system. That's kind of impractical. Most of the time when you're doing this kind of troubleshooting, it's going to be in the system, not sitting idly by waiting for you to come along and test it. And what this doesn't teach the watcher is how this component interacts with the system. This is impractical, of course, to real-world troubleshooting. No motor is sitting idly by waiting to be checked. In the real world, the motor may take hours to tens of hours to remove from the system. Let's start by working our way backwards through the system. Starting at the motor, walk your way backwards through the wiring. Make a list. A print will be very helpful for this. Take a look at the print I have pulled up here for you. Pause the video or go ahead and check out my link, and I actually have this already printed out, and you can go ahead and print this out from the website easily. Alright, write this down in this order: motor, disconnect, overload, contactor, fuses, and power. That's motor, disconnect, overload, contactor, fusers, and power. What the simple drawing fails to show you is the correct order to the three-phase system, how it's usually set up. For starters, the disconnect is usually close to the motor, especially in modern buildings. Disconnects are located close to motors for safety reasons. Lucky for us, they also make troubleshooting easier. Let's start at the nearest disconnect. Before turning the disconnect off, turn the motor off. Never throw a disconnect under load. With the power off, check for incoming line voltage. This is done by checking phase-to-phase voltage. Most three-phase systems in the United States use 480. The meter will use something close, maybe 470, 477, something like that. With the disconnect still open, let's check the motor. On the side of the disconnect going to the motor, with your meter set to resistance, check phase-to-phase. There should be almost no resistance depending on the size of the motor. Also check each phase to ground. With your meter still set to resistance, you should have infinite resistance. Any measure of resistance to ground is an indication that the motor is bad or soon will be. A more accurate resistance measurement can be taken with a megger, but if a meter can pick it up, it's certainly bad. For the sake of lesson, let's assume we found nothing wrong at the motor. You still have that list, right? Let's keep moving backwards. Let's check the overload. Most overloads have indicators that indicate when tripped. If the overload is tripped, do not immediately reset. Investigate the cause of the overload. Most overloads are caused by mechanical overload. If no mechanical cause can be found, megger the motor. If the overloads are not tripped, check resistance across each overload. There should be no resistance from top to bottom. Let's move on to the contactor. Start by checking from the top of the contactor for voltage. Check phase to phase. By doing this, you are also checking the fuses and incoming line voltage. If the voltage is correct, turn the motor back on through the system controls. Check phase to phase on the bottom of the contactor. If you're getting proper voltage to the top but not the bottom of the contactor, check for incoming control voltage. If you have incoming control voltage and incoming line voltage but not outgoing voltage, the contactor is bad. If you do not have incoming control voltage, the problem is not at the motor system at all. We walk through the system from end to beginning, and this should be done several times until you have memorized the circuits. In the future, I would not start at the very end. I would start at the contactor and verify control voltage. But it is important to understand the flow of the three-phase system before attempting advanced troubleshooting methods. The advanced method would look like this: control voltage to contactor, line voltage to contactor, voltage from overloads, and check motor. Do not move to using advanced methods until you completely grasp every piece of the three-phase motor system.
Expensive repairs eating into your budget? Tired of calling and calling for help? We show up on time. How many times are they going to swap out parts until they find the problem? Does the part even need to be replaced, or would a less costly repair be possible? Improve Maintenance. Improve Maintenance industrial and medical device. Repair at improvemaintenance.com. You can send problems our way, and you will always get a quote before a repair. Rush repair and shipping are available. You can talk straight to the tech that is working on your repair. Low diagnostic fee, all deliveries will be insured, rush repair and delivery available. Open communication with the technician. Improve Maintenance. ImproveMaintenance.com. Component level troubleshooting at a competitive price.